we will ultimately make sure the vehicle is safe to fly crews. The difference is where we draw the line between us and the commercial partner.
Commercial and government partnerships and contracts might not sound that fascinating. But when we're talking about certifying Boeing Starliner to carry humans to space, the challenges and complexities become a whole lot more interesting. Next, on the Rocket Ranch.
EGS Program Chief Engineer, verifying no constraints to launch.
3, 2, 1, and liftoff.
Welcome to space.
We'll hear from the certification lead for Starliner in a few minutes, who is responsible for something called burning down paper. But first up, we have Steve Payne. His job is to think through pretty much anything that can go wrong on launch day and how to make sure we respond to keep everything and everyone safe. All right, I'm in the booth now with Steve Payne. Steve, thank you for joining me today.
Hey, good afternoon.
Steve, rumor has it that you are a big fan of model rockets, so you can't get enough of rockets during your day job. You have to go home and do it as well. Is that true?
That is a true statement. I tend to get carried away with things you can put a rocket motor on.
Well, wait a second. So things you can put a rocket motor on. So I believe technically the answer to that question is you can put a rocket motor on anything.
Pretty much.
Have you experimented with such things?
Well, there is a room in my house with a boneyard of several things that I have put rocket motors on and flown, from crayon piggy banks to rolled up cardboard tubes from the middle of gift wrapping paper, and anything that you can make pointy and put fins on that's around my house will fly. I got a couple of years ago, they asked me to build them a model rocket for display for an event at school. It was a fundraiser. And so I said, well, what do you want? I said, a big rocket, about, your height and whatnot. So I said, sure. And, several weeks later, I showed up with a 15-foot tall, 2-scale Saturn 1B rocket.
Oh, yeah. Man, that's awesome.
Yeah, so, give me a rocket, I get carried away.
So, Steve, you're the kind of guy that I just run into you all the time. Like, I never know where I'm going to see you pop up, but I see you all the time, and it's a pleasure every time. Can you tell me kind of what your background is? Because I'm not even sure, because I've seen you in so many different capacities here.
Well, where do you want me to start?
Let's just say, what's your schooling been? What are your degrees in, or degree?
All right. I have a degree in mechanical engineering from Syracuse.
Okay.
Where I spent many freezing years. After that, I joined the Navy. I was a Navy pilot for a while. I flew the Tomcat F-14 supersonic fighter bomber. Did that for several years, and then after I finished my active duty career, I came out to Kennedy Space Center, and I started to work for one of our support contractors here, Lockheed Space Operations Company, doing payload operations. I used to load cargo into the shuttle's payload bay.
Is that like you personally would be the one to
I
put
was
things
the
in?
Operations person. No, I wasn't the technician. We have technicians who do all the turning of wrenches. We have the engineers who develop the procedures and decide how much torque everything should have. And then we have the operations folks, which is where my expertise lies primarily. And it's the person who makes sure that the people, the paper, the parts, the conditions, the schedules are all there so that it can gel and the operation can take place. And to grease the skids, make sure that if they have a hiccup of any sort, we're the troubleshooters who make sure that we overcome that hiccup and press on.
That's kind of a good segue point, I think, because we're here today to talk about the Commercial Crew Program and specifically Boeing's upcoming orbital flight test with their Starliner CST-100. And your role is actually kind of just that, of accounting for a day we hope never comes. Is that a fair assessment?
That is a fair assessment. It is like an insurance policy. It costs money, and you resent having to pay it. And for most of the time, you'll never need it. But the day that you do,
it's
you're
worth
covered.
Every penny.
Right. And
Yep.
If you don't have it, you'll wish you had. So my job, and it is sometimes unpopular, is to point out where we are unprotected and what kinds of things we would need to do to be able to mitigate whatever hazard there might be or respond to whatever emergency condition has taken place. And when things get ugly, I'm the guy that everybody looks at and says, Steve, fix it. and so I have to have a way to fix it. And it involves quite a bit of planning up front and setting up of structures and teams and mechanisms and communications and procedures so that when you do need it, it works smoothly.
So what's your official title right now? Just is it something cool like waste management specialist, or is it like is it more engineering than that?
No, it's kind of a prosaic term. I'm a launch integration manager.
Okay.
Which is that little fine print that says duties as assigned at the end of your job description?
Yeah, I think all of us have that somewhere in your job description, and most of us know that it's kind of a catch-all for stuff.
Yeah, well, that's 99.9% of my job is all that stuff because it doesn't belong to anybody else. We have engineers who are experts in a particular system, and we have folks that are focused on in-flight stuff. We have folks that are focused on fueling the vehicle, folks that are focused on engines or focused on avionics or other such systems. Somebody has to have a 10,000-foot view, see the combined picture, and put all the pieces together. That's what the integration part of the title is. And if you start to think, if you were going to launch a rocket somewhere and you had, starting from a blank slate, what would you need?
Yeah.
Well, you would need a launch team. Other than a rocket, you need a launch team.
Sure.
So in the early days of the program here, I was helping put together who's going to be on our launch team. What are they going to do? What are their functions? How do we plug into the commercial provider's launch team? What communications go back and forth? What channels do we need? What infrastructure needs to be there? What control rooms are necessary? So all that had to be thought out. And after much deliberation and back and forth, we came up with a plan. And so we put all that in place. Some of it is what are the operations that take place when the crew arrives on the center? Well, the crew office is focused on health stabilization, for example. If they arrive 7 days prior to launch, we don't want them getting sick before going up to the station. So there's all these involved procedures for making sure they don't get sick and take something up with them and make everybody on station sick. So we had to come up with a procedure for that. Last time we looked at it, we had a space shuttle procedure from the 2011 timeframe, and we had been using a procedure that worked in Russia, but we didn't have one for now, for this program,
Sure.
that incorporated all those changes and all the international piece. So we had to go create a new one. So it was integrating again, what do the Russians do, what do the Japanese want, what do our European partners need, what are our special situations here, and we rewrote the new procedure, got it all partnered in, and then we have to go execute that. So somebody had to integrate that story. It ended up in my duties as assigned bucket.
Yeah.
Things like emergency management. If you're at the pad and something goes wrong, how do you get off that pad? Well, we have emergency egress systems. Somebody had to provide input as to this is what we need, this is how we're going to get out, this is acceptable, this is not acceptable, and so help the design of that. So we influence the design of that. Okay, once you get off the tower, then what? How do you get out of there? Well, we had to provide them with vehicles that were suitable. We procured armored vehicles and modified them so that the crew could get away safely. All right, now once you've left, what happens if you're hurt? So we had to come up with a medical team to go check them out and make sure that we can patch them up if need be. If they have any propellants on them and they're contaminated, we need a decontamination team to go make sure that they're clean.
Are you the guy that's thinking through all of these things? Like, is that really your role?
That's
obviously you
my
can't
role.
like do all these things on your own, the application of it, but your job is to think through all of these minute details, and some of them are not minute, but you're
Right.
the guy.
Yeah, I'm the guy that points out, hey, you're going to need this and this and this and this and this and this. And they say, that's great, Steve. Go make it so. And I kick myself for opening my mouth so much. But we've gone and we've made it so. We'd worried about the medevac, and we found helicopter support. We've configured our helicopters. We worried about medical support. We've contracted with outside entities to provide us medical support. We worried about decontamination. We've worked with our KSC and Cape Canaveral fire teams to provide decontamination, and so on and so on and so forth.
Yeah. Are you writing the procedures for these kinds of things, or are you just are you a part of a team that's writing the procedures for these?
I'm pulling together the team that's
Okay.
writing the procedures. We run our emergency escape and rescue working group where all this stuff is discussed. And I'm the co-chair, and
Okay.
we provide guidance and make sure that everything that needs to be in place is there.
And I have this picture of you all, this team you kind of gathered together, just sitting in a room with a giant whiteboard, thinking of like what things can go wrong, and just like throw everything on a wall and then go from there. Like, is that a fair picture, or is there something more formal than that?
There is a lot of what-ifing
Okay.
and scenario development. If we have There are so many things that could go wrong if you let your imagination run wild,
Sure.
and we do
Yeah.
because usually life is more interesting than fiction. If you imagine a scenario, well, we had to leave the pad because bad weather was coming, and so we had to leave. Well, okay, how do you handle that? Or we had to leave the pad because something was starting to go wrong, and we wanted to get out before it got bad. Okay, that's another response. Or we had to leave the pad because, hey, we're leaking fuel somewhere and we need to get out of here.
Sure.
So that's another scenario. Or then there's a really bad day, something went kablooey, and we have to go get people up there. So we had to put together a team to go get them up there and procedures for that. So all these things are waiting in the wings to be called upon on launch day, should we need them. And if anything goes wrong, we've got aces up our sleeve for all kinds of different scenarios.
You kind of talked about the interestingness of fiction versus reality. Have you had any specific instances in the past that we've had a bad day or almost had a really bad day, and you've been able to use these kinds of applications? Or has this all still been like very theoretical for your world?
Well, we have. I've only really had issues during processing because, fortunately, we haven't had this happen to us during a launch countdown. But
Cool.
I used to work daily processing the space shuttles, and we every now and again would have a fuel spill issue. And we would find out that you can mechanize or make automatic all your response all you want, but there's people involved.
Yeah.
And people respond differently than machinery. We had one case where technicians were working on some pipes that had contained hypergolic fuels. And they weren't drained completely. We expected them to be, but they weren't. And so one of the technicians got an amount of this fuel on him. And the procedure is you egress the facility, you go out the nearest exit door, you go to the safety wash shower, you strip down completely, and you wash yourself so that you don't have chemicals on you. Well, if you consider human nature,
Yeah.
this shower is an open shower in the middle of the parking lot.
Yeah.
People don't want to strip down completely.
Sure.
We ended up having
That's what's going through my head this time. So I'm like,
It's
am
like,
I
I-
standing out in the parking lot doing this right now?
So he didn't, and we ended up. He was contaminated. The medical personnel that responded were contaminated. The ambulance they put him in were contaminated. And when he got to the hospital was contaminated. So it was one of those things. You integrate this, and so we started providing modesty garments.
Huh.
So that when you go out there and you strip down, you have something to put on.
Huh.
You're not just standing out there in
Yeah.
the buff. And the human nature part is the part that most people forget.
Right. Right. Ironically, I think you're 100% right.
Yeah. So when we try to design our systems and our responses that involve humans, we're trying to make them as simple, as intuitive as possible, so that if you're in a panic kind of situation, you don't have to do much thinking. There's one or two steps, and you're out of there. And that's how we try to design all our stuff. We had when we have an escape vehicle that we park at the base of the or near the perimeter of the launch pad, so that when the crew escapes from the tower down a wire that's hanging down, they'll end up at this vehicle and they can hop in and leave. Now we've done it so that the vehicles are running. We've done a checklist to make sure all the switches and lights and everything are the way they should be. All the sensors on board are turned on.
Gotcha.
Everything is ready. In theory, all you got to do is sit down, put it in drive, and take off the parking brake. 2 steps. 3.
Sure.
Well, we've had people screw that up. So
Because adrenaline does weird things to the
adrenaline
body.
does weird things. You forget, you put it in gear, it's not moving. Why is it not moving? Oh, yeah, the parking brake. You know? So we try to simplify things down to the minimalist steps we can.
Yeah.
We put big placards on, do this, then do that, and we train the crews so that they have that experience so that if they can't remember, their buddy next to them can tell them what to do. So there's a lot of that. Simplify, 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 so that it's human. It's second nature instead of allowing for people to mess it up, because people mess things up. They forget. So that's a big piece of the job.
Yeah, as I think about kind of the launch day, typically we have a launch manager, launch conductor, launch director, something like that. So assuming that kind of this bad day gets triggered, obviously that's kind of a broad statement of there's lots of things that could mean. Does control kind of switch over to you at that point, or does that person kind of maintain the conducting role through that procedure?
Well, we are plugged into the commercial provider's launch team. They run the launch countdown because it's their rocket, their
Yeah,
pad, their
an important
procedure.
distinction.
Right, and it's different than what it was for the old days when NASA ran everything. But we are plugged in as part of the team. When they call for the pad, for the crew or even the pad personnel who are out there, to tell them get off the tower, it's dangerous, go escape. At that point, we go into gear and we deploy our team. We tell our medical folks to start rolling forward. We tell our decontamination teams to go. We scramble our medevac helicopters so that they get in the air and start making their way out there. We coordinate with the launch conductor or launch director from the provider to count heads, make sure we got everybody. If not everybody got out, then we go send in pad rescue teams and recover whoever was left. Then we got to go treat all those people, and we got to package them and do all that, and then report back we got everybody and pass the information to their companies because it's not just NASA now.
Right.
I have to tell them, hey, person from company A, your employee ended up in this hospital because he was hurt. So those kind of things are how we plug into their team. And we coordinate in advance. Where are we going to send them once they get out of the rocket? What's going on? What's the weather? What are the conditions? Can we go back in or can't we go back in? All those kind of things are discussed as part of the team, and that's one aspect. Also in my job bucket is if we have what we call a pad abort, or SpaceX calls it a pad escape, where you have to essentially jettison the capsule. It's like an ejection seat, but the whole capsule goes with you.
Right.
So on a day like that, and the capsule ends up out over the water, floating in the ocean off the coast, it's up to us to deploy rescue forces. We work with the Department of Defense, and we send out helicopters with pararescue jumpers that jump out, open the hatch, get the crew out of there, and if they're injured in some fashion, they take them off to hospitals and medevac them out. So that part of the rescue response is ours too. So that's where the title right now. That function on launch day is called the Launch Rescue Director, and so that is my function on day of launch.
Okay.
And it's an interesting job.
A few minutes ago, you kind of mentioned the fact that this is a very different process than back with shuttle when it was just kind of NASA doing the space shuttle thing. Can you kind of give me a couple highlights of how is this different? Because ultimately we're kind of working arm in arm with Boeing, is my understanding, whereas with the space shuttle program, NASA, it was really NASA's program that we owned. So practically speaking, how is that playing out differently for you?
Well, back in the day when I was in the test director's office, the test director ran the countdown. The test director was also the launch rescue, landing and recovery director, which was one of the alternate jobs that we also had. And everything from running the count to doing the evacuation to handling the wounded to medevacing them off to the hospitals, or if we ended up in the water, that was our launch rescue director back then. If we ended up having to do a return to launch site, because with a winged vehicle we had that option, we could fly back. That was launch rescue director's job to set that up. If we ended up landing overseas because our engine snuffed out, that was a launch rescue director's job to do, or the landing and recovery director at the time. And if we ended up anywhere we shouldn't have ended up, in the middle of the woods somewhere with a vehicle, it was their job to go pick all that up. Now we share those duties with our provider. For scenarios where we land where we're supposed to land, the provider is there to handle all of that, not NASA. If we land maybe not quite where we intended to land, but near, well, the provider's resources are there, and we give them the lead on that, although we go assist because it's off nominal.
Okay.
If we land in the middle of the ocean, though, not in the designated landing areas, then that becomes a rescue operation, and NASA takes that into our own hands because we have the resources to do that, where the providers don't necessarily have that.
And would you point to us being a federal agency as the primary thing there? Because ultimately, like, we can kind of pull on the rest of the federal government to kind of jump in and help out, which I think is what we do ultimately.
Precisely, yeah. We have the ability to go to pull on our Department of Defense or other law enforcement and Coast Guard and miscellaneous other federal or state resources to go provide rescue assistance. In fact, if it lands overseas somewhere, we can call on the State Department and get foreign military forces to help us out. So,
are you thinking through that kind of stuff too?
That, fortunately, is another group, but yes. That's
Somebody
a lot
else's
more.
job, finally.
Yes, that becomes somebody else's job. But we have, for example, we fly, our profile for the space station takes us kind of up the coast over Newfoundland and then over near Ireland.
Sure.
If we were to fall into the ocean for some reason near Ireland, we'd call on their Department of Defense to help us out because they have rescue helicopters and ships and other such things. So we'd go to the State Department. We'd go first to our Department of Defense. We'd go to the State Department, ask for assistance. They'd contact our counterparts across the sea. They'd go respond. If we end up in some middle of nowhere and there are no other foreign agencies, then we'll take what's called the ship of opportunity. Who's out there who can go provide aid and rescue if need be?
Yeah.
And we send them instructions. This is how you open the hatch. This is what you have to be careful with. Please take care of our guys.
Yeah.
So there's all that planning and scenario. We do have also aircraft staged out of South Carolina and Hawaii, so that if we end up anywhere in the Atlantic, we can fly a large transport aircraft to where they are within a couple hours, drop rescue jumpers out the back, drop inflatable boats and other miscellaneous things to have at least a floating island of aid.
Sure.
And then we send whichever the nearest ship is to go help them out. The same in the Pacific. If we end up out there, we do the same thing. There's an aircraft staged out there. So there's a lot of planning, and it's a lot of coordination in advance.
Yeah.
And hopefully you'll never, ever, ever need this.
Yes.
But you still got to practice, and you still got to have the resources in place, and you have to convince people that they need this.
Steve, the commercial crew program has been in motion for about 8 years now, and it's been a lot of hard work. What's the feeling of the entire team, kind of as you're involved in this day to day? Obviously, you haven't flown the Starliner yet into space, and so that's still coming. How's the team, like, what's that feeling? What's that atmosphere like?
Well, you know that feeling you get when you have a final the next day?
Stress, usually?
Yeah. That feeling.
Urgency,
stress. Am I ready? Have we done everything? Have I studied everything there is to study? That is looming over the horizon. We know that we're getting very close. We've done everything. We know everything behind us is complete and all the T's are crossed and the I's are dotted like they should be. There's still a lot of work ahead of us that we have to get done in what appears to be a shorter and shorter time because the calendar doesn't stop for us. It keeps going whether we're finished or not. And we're shooting for a target date. That's always been the case with rockets. You pick a date and you say, we're going to be ready then. And sometimes you are, sometimes you're not. But in this case, we have a pretty good feeling that we're going to get there. And it's happening within the next month or so for us, a little over a month. There's still a lot of wickets we have to jump through. It's kind of difficult to keep the pace that we have been keeping because everything has to be finished.
Yeah.
And we have to get comfortable with everything, and everything has to work right between now and then. Because if anything goes funny, then it inserts questions and uncertainty into the schedule, and we don't know.
Sure.
But if everything works as planned between now and then, and we knock out all our scheduled activities as we have, we're going to get there. And we're going to get across that finish line having not much left to give because we're going to give it all we got getting there. It's like a runner. They say don't save it for after the race. Use it up while you're there.
Right.
And get through that finish line.
Time for a final.
It's time for the sprint at the end. So we're getting ready for that last sprint, and I'm very much looking forward to getting our first launch in the air and seeing the results of all those years of hard work pay off.
And as we approach launch day, how are you feeling about it?
It's kind of interesting. I got mixed feelings. Yes, I'm nervous because, I'm going to have to perform. I might have to have a bad day and be there and be crisp and be right because there are people in that ship who are counting on me, or there are people on that pad who are counting on me to have their back. On the other side, we have been practicing this and developing these procedures for a couple of years now, and we think we got it down. Obviously, there's always room for improvement, but we think we're in the 90-some% ready stage. So if it were to happen, we could deal with it. Of course, the The nervousness is still there.
As again, kind of factoring in the humanity of this whole thing, that's perfectly understandable. So this upcoming flight, the orbital flight test, is uncrewed, and then will be followed sometime thereafter by the crew flight test. And I believe I heard you had an interesting story with one of the crew members, Boeing astronaut Chris Ferguson. I've heard there's some good stories. You guys have worked together in the past. Is that true?
Yes, he and I went to flight school together back in the Navy. We were in the same training squadron for F-14s back in 1986. And we go way back. We have some embarrassing pictures of ourselves that that every now and again I'll drag out and we get a chuckle out of.
Very good. So yeah, it seems like this is a big world. There's a lot going on, but it seems like it can be a pretty small world as well as these paths kind of come and go and cross each other unexpectedly.
That's a true statement. The people who love this job as much as we do tend to stick around, and they feel great ownership and responsibility for what they're doing. I have never seen anywhere else but here that level of dedication and focus on the mission. I mean, I've had military background and I've had other such things, but here more than anywhere else, I see everybody pulling in the same direction, and they don't want to be the person that fails. Not because they don't want to be seen as failing, but because they don't want to fail their buddies. They know that we have friends on those ships, and everybody's counting on them, and you don't want to let your friends down. You find that in the best organizations. I'm sure you see that in your Navy SEALs and other such folks like that, where you know they're counting on you, and you will do your darndest not to let them down.
Yeah, as I look at the commercial crew program from outside, that is what I continue to see time and time again, of long hours, hard days, lots of effort, all kind of with that goal in mind. So, Steve, appreciate you being here, and I hope very much that on launch day you are incredibly bored and have very little to do.
I hope for the same. Thank you.
The orbital flight test is a major step on the road to certification. Here's Gennaro Caliendo with more. I'm in the booth now with Gennaro Caliendo, who, let me see if I get this right here, the certification manager for the Boeing Starliner. Or I think you might have said that there's more to it than just Starliner.
Correct. There's two pieces of it, or actually there's more than two pieces, but you've got the Starliner, which sits on top of the Atlas V, which is its launch vehicle. The two together form the whole part of the system. Of course, the system includes the ground processing equipment as well as the launch system, and it's all included. And that's what we certify. We don't certify just the Starliner. We don't certify just the Atlas V. It's the entire system.
Yeah,
from
and
start to finish.
I think that's a great point. I appreciate you bringing that up, just because people, when they think of a rocket launch, they typically only think of the rocket. But ultimately, there's a ton of work on the ground to be able to fuel and process and handle and support all
Correct.
the aspects of launch, and then even the emergencies that might be encountered.
Right. For instance, at Pad 41, where the Atlas V is going to launch from, we actually worked with the commercial provider. In this case, it was Boeing. Through their subcontractor, ULA, United Launch Alliance, which launches the Atlas V for Boeing, to create a system whereby we can access it. You know, the 41's been there forever, and it's been used predominantly for unmanned satellites and interplanetary kind of missions. ULA's used it over the years for commercial as well as NASA missions, as well as DoD missions. And so they had to actually modify it to support launching crews, and that meant building a big tower. So if anybody goes out there, you'll see this big tower that allows the crews to actually climb up to the top and ingress the CST-100, which sits on top of the vehicle, as well as provide for any emergencies. Those are in our requirements, and I guess we can talk about requirements here to allow the crews to get off in an emergency. For those of you that have seen shuttles fly, you may have seen some of the emergency systems that were out at the launch pad.
Right.
They're installing or have installed something very similar to that, but it also has a kind of a flavor of, if you've ever taken these, trying to think of the word, sort of rides,
The zip line
zip
kind of
lines, and
rides,
things
yeah.
like that. Thank you.
Similar but different.
Similar but different because their role is different. Obviously, you're getting
Sure.
away in an emergency. They actually put one of those zip line systems where people can escape in an emergency. That would mean the flight crews as well as ground crews that are out there, and they can transport them very quickly from that level down to the ground and then into protective vehicles until the emergency passes, or they can drive themselves out. Those emergency vehicles are ones that actually we provide to them as a government provided service or government provided equipment. It's the same vehicles that we use for I think it's Constellation or Exploration now, right? Not Constellation's the old word.
EGS.
Yeah, EGS.
Yeah, so, and I want to kind of backtrack because your title is certification manager.
Correct.
And so I've heard the phrase thrown around, burning down paper. I want to first say that we're not actually lighting paper on fire, right?
Correct.
Okay.
Correct.
So
That's
we're not
absolutely correct.
burning paperwork here, but this is
Right.
a phrase we use. So can you kind of talk about what does that mean and kind of as a certification manager, what's your job?
So my job is to lead a small team on the NASA side. You know, the thing about certification is in the commercial world, it has a slightly different flavor for us as NASA people. In the past, we had a set of requirements that we used to call level 1 or very high level requirements. And then we would create sub-tier requirements or level 2 and 3 and 4
Okay.
that would actually decompose at top level requirements. So for instance, if you said, which we do today, transport 4 people to the station and return them safely home, that would be your top level requirement.
Okay.
And then what we would do ordinarily, if it was a heritage NASA program, we would take that top level requirement and we would decompose it down into components, parts of that. In this world, in commercial, we leave it at the high level and we let the provider actually decompose it. Now, that particular requirement, in itself, we give the commercial providers some flavor of what we expect in there, but we leave it up to the provider to actually decompose it. So in that particular one, while it sounds like transport crew and return them safely seems very, very generic, there are words within our requirement set that says this is what we expect it to be. In that case, it's all about ascent trajectories and entry trajectories, entry, descent, and landing, and rendezvous and docking. It's all part of that. And so the commercial provider then provides the details behind all that. When we say burning down paper, what we mean is the contractor, in this case Boeing, in my case Boeing, will supply the evidence via actual physical documentation. Now, you know, we're living in a new sort of millennium. Paper is an abstract kind of thing.
Yeah,
so
even paper is
even
fluid
paper is
term.
kind of a fluid term, right? So they deliver a lot of this electronically to
Sure.
us, and we review it electronically, and we look to see if it meets the intent of what we were doing. So in a test flight world where we are today, not all the requirements are active or required for a particular test flight. So
Give me a for instance. What does that mean?
so we have approximately, there's somewhere in the neighborhood of 280 requirements that we said these are safety and performance requirements that are out there for Boeing, in this case, to meet.
Is that like the tier 1 level?
Yeah,
280 of those?
280 of those. And then we
Okay.
have an additional somewhere in the neighborhood of close to 500 and change of performance and safety requirements that are required to fly to the ISS. Those would be your International Space Station programs requirements.
Okay.
So between the two, we have approximately almost nearly 800 total requirements that they have to satisfy, which may sound like a lot to most people, but when you think about and you compare it to some of the other programs, they are probably those requirements are then decomposed
Sure.
into thousands of smaller, lower level requirements. We don't
Right.
necessarily require the decomposition at our level, but we do require them to decompose them and then roll them back up for us. Right?
So when you talk about this, because kind of you made this point of like in a heritage program, which I think is a great way to describe it, you have maybe thousands more requirements as a part of this. So does that really make our job easier or does it make our job harder? Because I could kind of see that going either way because we're a little bit more hands off.
Right. So yeah, Josh, that's a really good question. In some cases, it makes it easier. In some other cases, it does make it much more difficult because you leave it up to the provider to figure it out, and then you have our people, which have a lot of heritage history, and so they have certain expectations of what needs to be delivered. So there's a lot of give and take that goes along with that,
Right.
of what we expected versus what they delivered. And so sometimes those two aren't they don't flow very well together.
Sure.
So it's been a lot of back and forth between us and the commercial provider to figure out what the right level is. And once we get to that right level and we're satisfied they meet the intent, then we're good to go, and we move on to the next one. Now, not all of those close to 800 requirements are required for each of these test flights. So we have a sub-tier of those, subset of those that are required, what we call the minimum requirements. In the case of space station, that's mostly all of them, because in order to approach the AE, the spacecraft, in the case of our requirements, where you have an unmanned vehicle that's going to fly here, OFT, orbital flight test, there's nobody on board. There's certain subsets of those that we don't necessarily require to be completed, simply because you don't have people on board. For instance, the most obvious one is a requirement that we have for launch abort or abort systems, not just launch abort, but abort systems.
Yeah.
Since no one's on board, we don't necessarily require the abort system requirement to be satisfied. We leave that risk up to the commercial partner.
Okay.
In this particular case, I don't know if a lot of people know, but Boeing will have they have an abort system on board, but they only have part of it actually functioning, and that's on the launch vehicle. It's the emergency detection system. It will follow along, and it'll record events in the event of an abort trigger getting a red line getting triggered. It will record it, but it won't abort the vehicle. The spacecraft itself won't have the capability to abort. The big launch abort engines, for those of you that saw the pad abort test here not too long ago, those big engines that you saw that lit to launch the vehicle off the top, they won't be active on this flight. In fact, they won't even be there. For the simple reasons that it's just not required.
Sure.
But when we get to CFT, that requirement will certainly be part of the next set of requirements for crewed flight test.
Yeah, and before we started recording today, you made a comment to me which was really intriguing, that ultimately there are these things that have to be met before we'll let you go try and fly to space station.
Right.
But ultimately, those aren't actually the certification that you're really after, and that comes later down the road. Can you talk more about kind of what's really the end goal here? Yeah,
the end goal is to certify the entire system, right? You've got a commercial crew transportation system. That's the launch vehicle, the spacecraft, the ground systems, the personnel, the communication systems, the launch control centers, the mission control centers. They're all part of the entire system, not one piece of it. And so ultimately, these requirements that we have out there have piece parts associated with all of those aspects of a system. And so we wind up getting to a point where we want to certify the entire end product. And that's done through what we call the certification review. And that's typically done, or in our case, it will be done, post 2 test flights. And the 2 test flights, the first one here coming up here in December, is the unmanned or uncrewed version of the vehicle. The next one will be the crewed version sometime early next year. And then post that, there'll be a significant review where we look at all that data, we look at how the vehicles worked and how it functioned and how well it performed. And then we'll have the final sign-off, which is called certification review, which means the system is now certified to fly. And then post that, we'll have what we call post-certification missions, PCMs,
Awesome.
We'll be flying the crews on a fairly regular basis to station, about once every 6 months or so, right?
Yeah, and one of the things we talk about in our office some, and I'm just kind of curious to get your thoughts on the challenges that this presents, is that at no point in history has anybody ever done what we're trying to do.
Correct.
Because people probably, they may not realize that we're marrying commercial and government in a way that this has never happened before.
Right.
Do you guys feel that? Is that something that's feels like an impossible hurdle? Is it just hey, this is a cool challenge to undertake? What's the feeling amongst you and your team?
Oh, absolutely. It's some days it's really cool to be a part of it, and other days it's really, really challenging because of where a lot of us come from. I've been in this business about 30 years, over 30 years, and a lot of the people I work with have a significant amount of time in this business. Some of us has background in shuttle, some of us have background in station, International Space Station. Others have background in the launch services program. And then someone like me who has a little bit of all of that, it's difficult because in all those other programs, with the exception of maybe the launch services program, because they did do some hybrid of the model we're doing now. We've owned the hardware. We've owned the requirements. We've taken all of the liability and responsibility to ensure the safety of this vehicle. Not to say that that's not what's going to happen here. That is absolutely 100% going to happen here. We will ultimately make sure the vehicle's safe to fly cruise. The difference is where we draw the line between us and the commercial partner. This is a true shared, what we call shared accountability between ourselves and the commercial partner, where we allow them to kind of work a lot of the down and in details, and we look at the primary safety and performance requirements at the top, which is what I was sort of alluding to before.
Right.
All right. And so we don't dive down nearly as deep. So some days it's very challenging because of our expectations of what that is. And other days it's really a lot of fun to work with these partners to see how creative they can get.
Yeah. So probably the last question for you here.
Yeah.
Where are you going to get to be on launch day? Are you working, or you just get to be a spectator?
No, I'm probably going to help you guys out, I think.
Oh, good.
As I work for the Systems Engineering Integration Office, most of our work will be done before launch day. In
Very
fact,
good.
all of it should be done before launch day. And so I don't have an active role in the control centers. As a matter of fact, as part of the model we follow, NASA isn't really actively working the countdowns. They are there in a support role. We are certainly there in the go, no-go, final no-go, no-go role.
Sure.
And then we'll have some technical expertise that'll be listening in on the nets, on the voice nets and the loops to hear for any kind of issues that might be occurring during countdown. That group of people is a very small number. It's not very large, and they will be strategically positioned in the ASOC, where ULA launches the vehicle from. We'll have some people in, believe it or not, Mission Control Center Houston, because the Boeing model is actually using our NASA people to, in a sort of a subcontractor role,
Sure.
to actually fly the vehicle for them. They are working directly for Boeing. And so they don't necessarily work directly for us. However, in this interesting hybrid role, they do have and own and contain NASA badges. They are mostly NASA and NASA support contractors. This is kind of a unique approach for the Boeing model, and it's unique for us. But actually, in some ways it buys down a little bit of risk because they're using heritage people to fly the vehicle for them in a subcontractor role. Now, they ultimately answer directly to Boeing, and then we then provide through our commercial crew program the final go to actually fly to space station along with our ISS partners.
It seems like every time I talk to somebody about this program, there's more complexities that kind of pop up, which I love. And it just shows the resolve of our people and the commercial companies we're working alongside of to get the job done. Yeah,
so that it absolutely is. And so our role is sort of in a much smaller oversight sort of role, and we're going to support the team involved for making that last minute go or final go to fly. With a handful of people, as opposed to what you may have seen in the past with, say, the LCC over here, where you had several hundred people, and we were actively working the countdown. Not to say that Boeing/ULA won't have a similar number of people, although I don't think they'll have as many. They'll just be located here in the ASOC. They'll be located in Mission Control Center Houston, and then we'll have our people in various places looking over their shoulder and just making sure that everything goes as planned. Those people are going to be highly experienced people that have been working closely with Boeing over the last, in some cases, 8 or 9 years. So they understand the architecture very, very well. They understand, they've been working very closely. They understand any of the issues or concerns that have come up during the whole design, development, and test program that Boeing's gone through, and we've been there side by side with them. It's just not going to be a huge number. My role, even though I've been there the last 8 or 9 years with them, will be mostly done since I'm mostly the paper guy. And I'll be sitting there probably helping you guys maybe take some people around on launch day. Yeah.
Good. Well, Gennaro, obviously you have a busy couple weeks ahead of you, so I'm going to let you get out of here, but appreciate your time, and we're looking forward to seeing this thing fly.
All right, so am I, believe me, and so are we. Thanks.
I'm Joshua Santora, and that's our show. Thanks for stopping by the Rocket Ranch. And special thanks to our guests, Steve Payne and Gennaro Caliendo. To learn more about the Commercial Crew Program, visit nasa.gov/commercial crew. And to learn more about everything going on at the Kennedy Space Center, go to nasa.gov/Kennedy. Check out NASA's other podcasts to learn more about what's happening at all of our centers at nasa.gov/podcasts. A special shout out to our producer, John Sackman, our sound engineers, Michelle Stone and Lauren Maythree, editor, Chris Chamberlain, and special thanks to Marie Lewis, Tori McClendon, and Jen Wolfinger. And remember, on the Rocket Ranch, even the sky isn't the limit.